should be good. All right, so I'm here to talk about FREUD, and that stands for Feature Retrieval, Editing, and Understanding for Developers. Basically, it is an open source code base that allows you to do mechanistic interpretability on audio models. That QR code will take you to the GitHub repository, and the rest of this talk is me trying to convince you why you might want to check out this repository. So, first of all, what is mechanistic interpretability? There's this essay from one of the co-founders of Anthropic where he compares a neural network to compiled bytecode. If you have compiled bytecode, you just have like this bizarre, opaque blob of binary. You don't really understand what it does until you run it, try to reverse engineer it by looking for variables, understand how it operates on the variables. With a neural network, you just have this big, opaque blob of matrices. If you want to understand what it's doing in terms of logical steps, you want to look for features in this intermediate representation, understand how it operates on those features. So now is a really good time for mechanistic interpretability. Over the past 2 years, we've had a ton of breakthroughs in understanding how neural networks work. As an example, OpenAI has done really good work in understanding individual neurons in the multi-layer perceptron layers of transformer models. And one of my favorite recent results comes out of Anthropic. They used a technique called sparse autoencoders to find a feature in Claude Sonnet that corresponds to mentions of the Golden Gate Bridge. They turned it all the way up, and they got a model which obsessively talks about the Golden Gate Bridge. You ask it for the highest calorie food at McDonald's, and it will tell you how many calories are in the Golden Gate Bridge. Now is also a really great time for multimodal models, particularly models that listen to speech. OpenAI just released voice mode for ChatGPT, and if you don't want to deal with OpenAI, you can just go to Hugging Face and download an open source model that can listen to your speech and understand it. The problem is, all the great mech-interp stuff that I told you about has been for language models, and there haven't been a lot of work on audio processing models. So this screenshot here is this gorgeous GUI from the website Neuronpedia, which hosts resources for mechanistic interpretability on language models, but there's no equivalent for audio until now. So let's take the interpretability techniques that have been shown to work on language models and apply them to audio. And let's also come up with some UIs that allow us to interpret the, mechanistic interpretability results for audio. All right, and I have prepared a little demo for us so we can see FREUD in action. And this is exactly what you'd see if you cloned into the repo at the start of the slides. So first, let me record some audio. Okay, wow, it's recording. Test, 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 1, 2, 3. Okay, perfect. So here we're looking at the multi-layer perceptron layer of the speech-to-text model Whisper Tiny, basically trying to do something like that OpenAI research that I showed you earlier. So all of these are different indices in the multi-layer perceptron layer. I'm trying to find something that could be interesting. Oh, here's an interesting periodic pattern. Let's take a listen. Okay, so these green bars basically tell you where the highest activation is, and I have a hunch this maybe corresponds to like the S phoneme, but we can try to verify the hypothesis. So the index feature is 1370. Let's see what other audio activates this feature. All right, so we can just try to listen to the audio around the green bars. Interesting. So it does seem like it's activating on the S sound, but also a little bit on like a ch sound. I think I heard like a sh back here too. Interesting. And if we had more time, we could repeat this process, listen to more clips, formulate more hypotheses. We could even try to manipulate the value of the feature and see how that would affect the output transcript. But in the interest of time, I need to get through this whole deck, so back to the grind. So interesting stuff that I've discovered with this UI. I did find one preliminary work on specifically analyzing the smallest model in the Whisper family, and I managed to replicate all of those results. So that was pretty cool. I've also implemented the same technique Anthropic used to discover the Golden Gate feature for various models in the Whisper family, and you can download those checkpoints off Hugging Face. Additionally, what I think is my most interesting result is I found features that don't correspond to speech at all, but actually correspond to background noise, to laughter, even to animal sounds, which I think is kind of weird because we train these models just to do transcription. Like, why do they also understand all of these other sounds? Kind of spooky. So what I have to offer is the only open source library that allows you to train sparse autoencoders for audio. And I've also spent a lot of effort trying to make it easy to run on consumer devices. All of the work that I've done was, all of the models I've trained were trained on a single consumer GPU in under a day, which is great. It makes it super easy for anyone to contribute, whether you're a GPU poor academic or just like some random dude with a gaming computer. What I'm looking for is collaborators, people that want to train their own sparse autoencoder models using my library and look for interesting features. I also am interested in people that want to iterate on the sparse autoencoder design and also expand the GUI, add more interesting stuff for clustering, for statistical analysis of features. And currently, I just support models in the Whisper family, but I'd love to extend the code base to support other audio models like Hubert and WAV2Vec. So if you're interested in working with me, that's my email up there. And as far as background goes, I've worked on AI speech models for 2 startups. And I've published before, like a speech conversion model. It's up on GitHub. And yeah, thank you for listening.